so last full unit that we're going to cover is on 6.3 and 6.4, and it's on what we call exponential functions. So when we draw things in class, like what have we drawn mostly this year? Things that look like what kind of shape? Like
a shape of
when we graph things.
like a line.
Yeah, lines. All right. So that's pretty much what we've drawn all year. Okay, we've drawn things that look like straight lines. What we're going to look at in section 6.3 and 6.4 is things that look more like this. We're going to look at things that curve, okay? And they're going to curve either up very quickly, or they could also curve, let's do something like this. They could also curve down very quickly. So that red and the blue graph are the two things we're going to look at. One of these graphs right here is an example of what's called exponential growth, because it's curving up as you go to the right. The other one is an example of what we call exponential decay, because it's curving down as you go to the right. Okay, so we're going to look at both those kinds of graphs. We're going to do a little bit of graphing, so we'll learn how to plot points and make a sketch. We're also going to look at how we can figure out equations, okay, from a table. Like what's the formula for this graph in blue? If you didn't see me type it in, but what would the formula be if you had to figure it out from some points? All right, so first thing, let's talk about what is an exponential function. Well, first of all, it's not going to be written in the form that we're used to. What's the equation that we normally use for a line? It's the y equals what? Yeah? mx plus b. Good. So normally when we write the equation of a line, it's y equals mx plus b. These aren't lines, so we're not going to have the formula mx plus b. We're going to have a formula that looks a little bit different. Right, so what is a formula that's going to look like one of these graphs that curves? Well, it's called an exponential function. So after the part that says and, that's highlighted in yellow, you guys want to write down exponential function is a function that has this type of formula. There's a b in it, like y equals mx plus b. But the b is not a y-intercept. So we'll talk about what the b is. Right, and there's two arrows that are coming off the y and the x you'll see in a second. We're going to write down what those are. Now this part you guys already have where a can't equal 0. That's written as the first bullet right below the line. So that's one thing that's important. When you write a function that's going to have this kind of curve, you can pick a lot of different numbers for a. But one thing you can't pick is 0. You can't have it be a 0. And the other thing is about b. Okay, you guys have this already written down as the second bullet. You can pick a lot of different numbers for b. But if we're going to talk about something that's going to specifically grow, okay, as we go to the right, that's going to curve upward, then b has to be a number bigger than 0. Okay, so b, it's got to be a number bigger than 0, but it can't be 1. Okay, I'll show you what happens if it is 1, but it can't be 1. So let's look at what I did here. And let me just put this in. And let's see if you guys can identify what A and B are in this formula. All right. Oops. Let me Get rid of that little mark there. All right, so look at the blue, okay, the one that says y1. Anybody think they can tell me what is a on that first line? If you compare what I wrote to the formula that's in the box. Yeah? Yeah. In this top one, a is 1. And that's okay. As long as a isn't 0, you're good. And what about b? Anyone think they see what b is? So b is the number that has the variable as an exponent. Yeah, b was 2. And again, the condition for b is it has to be a number bigger than 0, but not the number 1. Is 2 bigger than 0? Yeah. And is 2 the same as the number 1? No, then that's fine. Picking the number 2 is something you are allowed to pick. How about the red one? What's a in that one? Oh, great.
What?
What's a in that one?
Sometimes 2.
So looking at the red one, and we're trying to match up this formula to what's in that box.
The X.
No, not the X, the A. We're looking at what the A is. So like if you match up,
In the problem, it's like
yep, it's a number.
I don't know what it's called because it's like that like hash one.
You know, help them out. What number? Yeah, 1. The number that you're multiplying by that's in front of, well, the next question I'm going to ask you. That number is the A value. Comes right after the equal sign. And that's 1. Okay. How about the B value? What's the B value in that one? Yeah? Careful, you're looking in the right spot, but not 5. It's what's in front of it. Point 0.5, yeah. So it's 0.5. So 0.5 was the B value in this one. And if you notice, there's a big difference between the blue one and the red one. One of them curves up as you go to the right. The other one curved down. Whether it's going to curve up or curve down depends on the B value. And we can also control how quickly it curves up. Some curve up faster, some curve up a little bit slower. Okay, so we'll look at some different examples. How about if I did one like this? Let's say y equals 3 times 4 to the x. What's my a value in that one? Yep.
3.
Yep. A value is 3. How about the b value? Yeah. 4. So the a value is always the number right after the equal sign, and the b value is the number that has x as the exponent. And we'll talk more about what those a and b mean, but for now, just being able to know which one is which, that's kind of the goal. Okay. Here's a couple more examples. In that case, a is 3, b is 2. And in this case, a is 4, and b is 1/2. And so any question on identifying which one is A and which one is B? Okay, so we're going to use this formula 3 different ways today. So for this part, you guys can just watch this. You don't have to write anything for this. And I think I kind of already said this. I'm going to give you a table, and we're going to see if from the table you can figure out a formula. The next thing is I'm going to give you a formula. We're going to see if you can draw a picture of what I give you. And then the last thing we're going to do is we're going to compare two graphs. Let me show you an example of that. Let's see, it's something like these two. Okay, 1 times 2 to the x and 3 times 2 to the x. They're pretty close, right? They have one of the values is the same, and one of them is different between the a and the b. Which value here is the same for both of them? The a value or the b value? Yep. The b value. What is the b? Yep, b is 2. What's different is the a value. In the top one, it's a 1. In the bottom one, it's a 3. Well, if I hit graph, let's see what the difference is. So there's when the a value is a 1. And there is where the a value is a 3. So I told you sometimes you can make your graph curve up sooner. So we're going to learn how to describe the difference between these two. We can't just say, well, the red one curves up sooner. We gotta say something a little bit better. But one thing you'll notice is, remember here, the a value is 3 on the red one. Now, look at that graph. Where does that red graph look like it crosses the y-axis? Yeah?
Around 2.
Sure, it crosses at 2. You think it crosses right here, the red one?
Oh, no. Oh, yeah, is that
3, yeah. So, yeah, it crosses at 3. And what was the a value in the red? You remember? Yeah? It was 3. So that a value has something to do where the graph crosses the y-axis. The red one crosses the y-axis at 3. The blue one crosses at 1. The blue one had an a value of 1, and the red one had an a value of 3. So that kind of gives you a little bit of a hint at what the a value does. It controls where it crosses the y-axis. That's one thing it does. Right, so we'll learn a little bit more about what the a value does when we compare one graph to another. All right, so first of all, exponential functions, you don't have to write this part down, but they're not linear. Linear means they're in a straight line. These are not straight lines. They're either going to look like that, or they're going to look like that, curving up or curving down. Let's look at an example of something that is linear, okay, something we've done before, and then we'll look at an example of the kind of table we're going to do today. Okay, let's start with a linear one. So what I've done is I'm going to make a table of values. And I picked 4 numbers to put in the table, 5 numbers. And I made sure each number was 1 apart. It doesn't really matter how far apart they are, as long as they're all the same apart. Okay, I could have done like +2 each time or +3. But I just want to pick 5 numbers that are equally spaced. Okay. Now, let's plug these numbers in one at a time for x and write down what we get. Let's start with -2. Maya, what's, if I plug in -2, what's 3 times -2?
-6.
And then -6 plus 2?
-4.
Yep, perfect. So we get -4. Anaya, let's do -1. What's 3 times -1?
-3.
And what's -3 plus 2?
-1.
-1. There we go. So there's that one. Caleb, what if we plug in 0? What's 3 times 0?
0.
And then plus 2?
2.
2. Okay, so we get 2. Abby, what about if I plug in +1? What's 3 times 1? And then plus 2? 5. And Emily, my last value I need to plug in is 2 for x. What's 3 times 2? 6. And then plus 2? 8. Now, I want to look at this bottom row. Does anybody see the pattern of how we got from one number to the next in the y values? It's like we're doing the same thing each time as we move to the right. Yeah, exactly. We're adding 3 each time. If you have a table and the pattern is adding the same number each time, that makes it a straight line. Makes it a straight line when you draw it. So if adding a number each time makes it a straight line, something different for the pattern is going to make it curve. And that is what we're going to look at next. So let's look at that. All right, so here's an example of an exponential function. What's a in that function? Yeah, 2. Yeah. And what's b? Yeah, 3. So we're going to do the same thing we just did. I picked 5 values. They're all spaced apart by 1. That's generally what we want to do for the x's. And then we're going to make a table and see what we get for the y's. And we're going to look at the pattern this time. I'm going to give you a hint. The pattern is not going to be adding a number each time. Last time it was adding 3. It's not going to be adding 3 this time. All right. So let's use our calculator just to kind of speed up finding these x's. I'm going to plug each one of these numbers in, one at a time, for x, and see what my calculator gives me. All right, so let's start with the first one. 3 to the negative 2. 3 raised to the negative 2. And your calculator will automatically give you, I think it'll give you a fraction. Okay, that's 1/9. And then times 2. 2/9. So that's our first one. 2/9. Right, let's do the next one. What's the next x value that I need to plug in after negative 2? Yeah, negative 1. So I'm going to use my calculator. 3 to the negative 1. And again, your calculator will give you a fraction, 1/3. So now I need to take 1/3 and multiply it by 2. What's 1/3 times 2? Well, okay.
I don't know.
So think if you double 1/3, how much, like 1/3 plus 1/3, what would you have?
2/3.
2/3. Okay, and the next one, 2/3. All right, let's do 0. This one, let's see if we can do without a calculator. What did we say last week? If you raise anything to the 0 power, what do you always get? Yeah, 1. So when you plug in 0, 3 to the 0 power is 1. And then what's 1 times 2? Yeah, 2. It starts to get a little easier when there's no fractions. All right, let's do the next one. 1. Joe, what's 3 to the first power? 3. And then, good, 3 times 2. 6. Yep. So there's that one. And the last number we need to plug in is 2. Dorian, if I plug in 2 for x, what's 3 to the second power? 9 times 2. 18. Okay, so there's our y values for this one. It's probably easiest to focus on these numbers because they're not fractions. If you're looking for a pattern. Okay. Let's see if the pattern is addition. To get from 2 to 6, what would you add? Yeah. You'd add 4. So let's see if that works when we do it again. If you add 4 to 6, do you get 18? Yeah? No, you don't. Yeah, you don't get 18. So the pattern here is not adding 4 each time. What's another way to get to 6? Besides adding something to 2, yeah?
Times by 3.
Times by 3. Okay, that's a different pattern. Timesing, not adding. Let's see if timesing works. So if you times by 3, you get 6. What if you times 6 by 3? What do you get? Yeah? 18. That's the pattern this time. Timesing by 3. And any time that the pattern involves timesing, that's going to give you a graph that's going to curve. Okay? That's how we know if we're looking at a table that the table is going to give us points that curve. The pattern involves timesing. Okay. Now, what if the pattern involved adding? What did we say that was? If the pattern involved adding, that's going to give us, linear. It's going to give you a straight line. So if the pattern is adding, straight line. If the pattern is multiplying, curve. Okay, so you got to figure out what the pattern is. Okay, that's the first thing we have to do. Any question on the difference between those two patterns? How one was adding and one was multiplying? All right, so let's see. Okay, so this part is back on your guided notes. And this is how you figure out the A and the B in the formula. Right? Because those are the two things you have to find. Well, first of all, the y and the x, don't worry about the y and the x. Okay, the y is going to stay the same. The x is going to stay the same. Bless you. Those are the two things you have to figure out from your table. Let's start with A. The way that you figure out the A value is you're going to look at your table and you're going to go to the column where you see a 0 for x. Once you find a 0 for x, you're going to go down and you're going to read off the y value in that column. That is the A value. So let's go back and look at this last one, for example. It says to find where x equals 0. Okay, that's that column right there. That's where x equals 0. And then read off the y value in that column. Sorry about that. Okay, so looking at this table, you look for the x value, where it's 0, go down below it, and read off the number that's below. In this case, it's a 2. That means if we were going to write a formula for this table, the A value would be a 2. It's always the number that's below 0. That's how you get the A value. Now, look, before I even show you the B value, look at the table, and does anybody think they see where the B value comes from in the table? I don't think they see where, well, what is the B value? John? What's the B value? 3. So does anyone think they see where a 3 came up when we did this. Three is involved in this problem, in this whole table somehow. It's not a number in the table, like A is, but it is something to do with the table. Yeah? Yeah. It's what we multiplied by each time to get from one number to the next in the row that's y. So this is the b value. It's what you multiply by each time to get from one number to the next. Let's write that down. So the b value is what you multiply by each time to get from one number to the next. So A is a number directly in the table. B is a number that you can figure out by looking at the pattern in the table. So now we'll try a couple examples where I give you a table and you figure out what the formula is. Remember, this is the format you're looking for. Y equals A times B to the X. This is like your Y equals MX plus B. That's the basic formula that you're always going to use. Okay, does everybody have how to find the A and the B from the table? So at the bottom of the guided notes on the first page, there are two examples. We'll go through example 1 together, and then I'm going to let you guys try example 2. All right, so the first thing you want to check in the table, and this part's important, is the x values have to go up by 1 each time. Do the x values go up by 1 each time in that table? Yeah. So I'm always going to give you a table where the x values do that. Okay. If the x values didn't go up by 1s, then what I just explained to you to find A and B would not work. Right, so there's our table, and they want us to write a rule, which basically means a formula. Can someone remind me, what's the formula that we're using? It's not y equals mx plus b. That would be if it was a straight line. Yeah. Yep, y equals a, b to the x. And what are the two letters that we have to find there? We have to figure out the A and the B. And what are the two letters that we don't do anything to? We just leave them the same. Yeah? It's the Y and the X. So I can already tell you the final answer is going to look something like that. We need to find what number is going to go here and what number is going to go there. Okay. Let's start with A. Remember, A is a number that's in the table. So A is one of those numbers. Does anybody remember how you find the A? Okay, so look back at your guided notes, if you're not sure, and read what it says for how to find A. It says A is, and then it tells you what to do. Yeah. A is the Y value, so you're picking a number from the Y row. And he said the Y value when X is 0. So looking at that table, how about Mia, what's the y value in that table when x is 0? 8. No. It's always the number that's below 0. That's the a value. Okay, so I'm just going to put that off to the side. A is 8. And how about the b value? How do we get that? That's not a number in the table. Yeah?
It's when you multiply each y value by as the x increases.
Right. As the x is getting bigger and bigger, what do you multiply by each time to get from one number to the next? So, Jacinda, let's go through it. What do you multiply by to get from 2 to 4?
2.
So you do it times 2. How about from 4 to 8?
2.
Times 2 again. And then 8 to 16 times 2. As long as the pattern continues that what you just said, times 2 each time, then we're going to know our b value. If all of a sudden it doesn't do a times 2, then we got a problem. But 16 times 2 is 32. Okay. So we know what we're multiplying by each time to get from one number to the next. So what's my b value? Yeah, 2. My b value is 2. Okay. So we've got the a, we've got the b. Take those two numbers and fill them in for the a and the b, and then that's your answer. So it's 8 times 2 raised to the x. That's how you come up with the formula for that table. And if you're wondering, well, what do you do if there's no 0 in the x row? Because I said you always look for the number that's right underneath 0. There always will be a 0. Okay, I'm going to make sure there's always a 0 in the problems I give. Any question on that? Now, if you look at this one, it's times 2, okay, each time. But what if I gave you a pattern of numbers? Just watch this part, like this. Let's say 40, 20, 10, 5, 2.5. What do you multiply by to get from 40 to 20? And if you're thinking divide, you can't say divide. You always have to think of it as what you multiply by. Yeah? Well, if we did 40 times -2, that'd give me -80. So it's not going to be a negative number. In fact, we'll never have a negative number for b, so you don't have to worry about negatives. Yeah? 0.5, or you could also say 1/2. So if you notice your numbers are getting smaller each time, then you're probably going to be multiplying by a fraction. And that's fine. This just means the b value would be a fraction. So it's never going to be a fraction that's that hard to figure out, but it could be a fraction. Okay. So if the numbers are getting smaller, probably going to use a fraction. If the numbers are getting bigger, well, then it probably will not be a fraction. Yeah. Yep, just sign out. Okay, so why don't you guys take a second and see if you can figure out that one. So you've got your table. Start by figuring out the a value and your b value. And then once you have those two, plug them into your formula. Okay, and we'll check in with you guys, and if you get stuck, just call one of us over. Okay, so let's take a look at this one. So remember your formula. That's the first thing you want to write down. Can somebody just remind me what's the formula we're using in this section? You're doing great. Just hoping somebody else will give it a shot. Yeah. y equals a times b to the x. So the a and the b are the two things we need. Which one of those two letters is in the table for you automatically? You don't have to do any math to figure it out. Yeah? The A. How do you find the A in the table? Where do you look? Yeah? Yes, it's the number that's right under the 0. So in this case, A is 27. Okay, so that's half what we need. Now B is a little bit more work. B is not in the table, but it's something we have to figure out about the table. Which row do we look at to figure out the B? The X row or the Y row? Yep. We got to look at the Y row. We've got to figure out the pattern. And if you figure out the pattern for the first couple, then you're probably good. Okay? Because usually the first ones are smaller numbers, so it's easier to do. How do you get from 3 to 9 with some type of multiplication? Yeah? You do it times 3. How do you get from 9 to 27? Yeah? That's also a times 3. And you might need a calculator at this point, but if you do 27 times 3, you will get 81. And if you check 81 times 3, it is 240. So what's the B value? Yeah? What is it? B is 3. So now, take those two numbers, fill them in, and write your final answer. Just make sure you put a dot between the A and the B, because if you don't, it's going to look like this. To me, that looks like 273 to the X. You got to put a dot in there. So we know A is 27, and B is 3. And that's your final answer. Okay, so that's the first skill. Taking a table and making a form. Any questions on that? Okay, so second thing is, how do we do a graph? Well, to do a graph, you have to make your own table. Okay, so this is on the back of the guided notes. You guys have a table and a graph already set up, but we have to figure out how to make that table first. All right, so step one. Well, step one, you're going to do what I've been doing for you. You're going to take the numbers -2, -1, 0, 1, and 2, and you're going to fill those numbers in for the X values, just like I've been doing in the table for you. You have to pick those 5 numbers, no, but those are the easiest ones to pick, so I would recommend doing it that way. So you're going to pick those 5 numbers. Okay, once you pick those 5 numbers for X, you need to plug each one of these numbers in, one at a time, into a formula that they're going to give you. So they're going to give you the formula this time. And you're going to plug these numbers in one at a time to the formula. So you're going to get all the Y values. Okay, we'll review what you do for a negative exponent. Like if you don't remember what happens when you have 2 to the -3rd. Remember, negative exponent means you need to take and put it in the bottom of a fraction. Okay, so that's part of what we did last week. So if you don't remember that, you might want to write that down. Negative exponent means you need to take that number with the negative exponent and put it in the bottom part of a fraction. So in this case, this would be 1 over, what's 2 to the 3rd power? Yep, 8. Yep. Okay, so now you've got a table with your x values. You're going to plug them in one at a time. You're going to get your y values. And then there's a spot here where you can write what I call the xy column. So the xy column is going to look like a column with a coordinate. We're going to generally do 5 coordinates to make a picture of one of these curved graphs. With lines, we usually just do 2, and then just connect them. There's your line. But since this is going to curve, we need about 5 points, and that'll generally give you a pretty good shape for your curve. So we're going to have 5 points. And then the last step is to graph your points. And remember, everything we're graphing this week should be curved. So if you end up with points in a straight line, something didn't work. Yeah. Yeah. Alright, so we'll go through one together right now of how you create your own table and then make a sketch. Okay. Does everybody have the 4 steps for how to graph exponential functions from a table? So that's the first one they want us to do. Y equals 2 to the x. Now, if you look at that one, you might think, well, wait a minute, the a value is missing. Right? It's like normally, we know the number that's raised to the x is the b value. So b is 2. But you could imagine, if you want to imagine an a value, what number, if you don't write it, is always in front of something? Yeah? 1. So you could imagine that the problem says 1 times 2 to the x. But when a is 1, you don't need to write it, because multiplying by 1 doesn't change anything. So I would probably just leave this the way they have it. But if they asked you, what is the a value in this problem, you would say 1. The b value is 2. Okay, so let's make our table. All right. First thing I need to do is write down what I suggested you use for x values. Can someone tell me the 5 values that I recommend you use for x? Yeah, Lexi. Yep, that's your first step. -2, -1, 0, 1, and 2. Now, what do I have to do? I'm going to have to do it 5 times with each one of these numbers.
What was the question?
What do I have to do? I'm going to do it 5 times with each one of these x values.
Multiply them?
What do you mean? So let's do -2 specifically. What would you do with that one?
I don't know.
Well, what are we trying to find now? Ultimately, we're trying to find a graph, but we don't have enough information to complete this column yet, this third column. Because I still need to figure out, yeah?
Multiply each by 2.
Well, let's just back up for 1 second. What are you trying to find?
The y.
Yeah, we're trying to find the y value. And this is the formula for the y value. Can you read me what that says to do?
Y equals 2 times x.
2 raised to the x, right? So there's no multiplication when we read this off. It's 2 to the power of x. So let's start with -2. So the first thing we have to plug in is -2 for x. And we're going to get this. Now, we went over the rule for a negative exponent. We don't want to leave it as 2 to the -2. How do I fix it so that I do not have a -2? Yeah.
You make it to fractions.
Okay, we're going to make it into a fraction. And what's going to be my fraction? Say it again.
Positive 2. Positive 2.
Well, the first part, it's going to have 1 in it, right? So it's going to be 1 divided by something. The exponent becomes positive, and yeah, what would go in the bottom? 2 squared. Yeah, 1 divided by 2 squared. So 1, you could say 1 divided by 2 squared or 1 over 2 squared. But you've got to say 1 over something. Okay, so there's my y value. And what is 2 squared? Okay.
2 squared would be 4.
4. Okay, so there's my first y value. Let's do it again. Sophie, what's my next x value I need to plug in?
-1.
-1. So now we're going to have 2 to the -1. How do we write 2 to the -1 so it doesn't have a negative exponent? Yeah? Perfect. 1 over 2 to the first power. And what's 2 to the first power? 2. Now, that's going to be it for fractions for the y values. From here, we're going to start getting nicer numbers. All right. How about Aiden? What's my next x value to plug in? 0. And if we plug that in, what's 2 to the 0 power? 1. Anything to the 0 power is 1. Okay, Annika, what's my next x value? Well, what's the last one we plugged in? 0. So we plugged in 0. So my next one I want to plug in is 1. And if I plug 1 in for x, what's 2 to the first power? 2. So that's that one. And now the last x value I need to plug in. How about Dorian?
2.
2. Plug that in for x. What's 2 to the second power?
4.
4. Okay, so there's my y column. So I got my x's, I got my y's. Now put them together like that to make a quarter. -1, 1/2, and we're going to graph all these in just a minute. Brady, what's my next coordinate?
0 and 1.
0, 1. Maya, my next one?
It would be 1, 2, and 2.
1, 2, right?
Yeah, that's what I meant.
Okay. And then the last one? Yeah. 2, 4. Okay, so that's how you make your table. You take the x values, plug them in one at a time into your formula, and get your y values. Now we need to graph all those points. Okay. -2, 1, 4. Let's start with that one. So -2. Right? Just barely up. Right? Just up a little bit. The next one is -1, 1/2. That's up a little bit more. Anaya, what's the next one?
0, 1.
Yep.
1.
And how would you graph 0, 1?
At the 0, and then you go up 1.
Yep. Let's go up 1. So far it doesn't really look like much is happening. When we start to get after the y-axis, That's when you're going to start seeing it curve. Okay, Abby, what's my next value? What is it?
1, 1, 2.
Yep, 1, 2. And how do you graph that one?
Go up 2.
Before you go up, you got to do something else.
Go to 1.
And which way? Is that left, right, up, or down?
Right.
Yep, right 1, and then
Up 2.
up 2. Perfect. Right 1, up 2. All right, and here's on my last point.
Right 2, up 4.
Right 2, up 4. And now we can really start to see it curving. So now from there, draw your curve and just draw it the best you can. Okay, so it's going to stay very close to the line. And then all of a sudden, it starts to curve. And that curve doesn't stop. It keeps going. But the graph paper is only so big, so that's what we do. Okay, and that's the second thing for today, making a sketch from a table. Any question on it? So we might just have to review a little bit what happens when you have negative exponents. Just remember it causes it to flip and go to the bottom. All right, so that's example 3. And now the last one. So the last one is when we're not going to sketch anything. All we're going to do with the last one is write a sentence. So here's an example of something I would give you. Let's say something like this. And I would ask you to compare these two. First of all, you can only do a problem with a compare if those are the same. We're not going to compare something that has a different number here and a different number here. When you do a compare, these two numbers will always be the same. These are going to be the numbers that are different. And we're going to explain how you write what's happening. All right, so let's take a look. Do you want to do this one? Hold on one second. Let me see. All right, this one, you know what? I'm just going to have you look at this one. You don't have to draw this because I'm going to show you some pictures. I'm going to draw two different things. I'm going to draw this one on the calculator, and then I'm going to draw the same one, except I'm going to put a negative in front of it. Okay, so here's, you know what, let me do it so you can actually see it happening. So I have 3 times 2 to the x, 3 times 2 to the x. Now let's just start with that. Okay, so there's 3 times 2 to the x. Now I'm going to add to that negative 3 times 2 to the x. Yeah. Yep. So let's do negative 3 times 2 to the x. Can anyone explain to me what happened? How would you describe the blue one compared to the red one? Yeah, it's like it was flipped, right? So if this was like a piece of paper and you folded it right on the x-axis, the blue one would land right on top of the red one. So that's an example of what we call a flip. So when we deal with a problem that takes something and puts a negative in front of it, we're going to see that that negative causes a flip. All right, let's try. So there's the example of the flip again. Let's try something like this. Let's take that graph, see if I can make a copy of it. Put it right there. I'm going to go like this. All right, so that's normal. What did I just do to that top one? I think they could explain what I did there. Let me do it again. So I'm going to take this one. All right, so I could do something like this, which I'm not doing. I'm going to do something like this. How would you explain what I just did to that graph? In terms of maybe, say, some type of stretch or compression. Yeah?
You compressed it down to a smaller size.
Yeah, I compressed it down, right? I compressed it vertically. It's like I squished it. Now the opposite of that would be taking and doing something, if that's the original, doing something like this. That's stretching. So those are the two main things that we're going to look at when we have a graph like this. We're either going to take and kind of compress it down, or we're going to take and we're going to stretch it. Those are the only two things we're going to look at. All right, so let's write down what happens. So this is on the comparing exponential functions from graphs. So I know we looked at one that had a negative in it. We'll do the negative after. Let's just focus on right now if it's a positive value. The A value causes your graph to either stretch, bless you, or compress. If you have an A value that's bigger than 1, that will stretch your graph. Which way will it stretch it? Vertically. Here's an example. Let's take something like 1 times 2 to the x and 5 times 2 to the x. I change the A value to a 5. And watch what happens. That's the original. And that is the new one. So what happened is it stretched. And if you can't quite see how it stretched, well, I can show you. Here's the original. Does something like that. So take that graph and stretch it. So I stretched it vertically. Probably stretched it too much. But now line it back up. Actually, no, I did. Actually, I did okay with it. Looks pretty good. By stretching it vertically, it now has this shape because it's stretched vertically. The more you stretch it vertically, what's going to happen is the sharper and sharper that turn is going to be. So now I've stretched it a little too much because it's curving up a little bit too soon. I did too much of a stretch. The way I had it before was perfect. I stretched it a little bit and then I lined it back up and it lined up exactly with the graph. So if you put in a number that's bigger than 1, causes your graph to stretch. And the way that you always write your answer is exactly what this sentence says. You say vertical stretch by a factor of, and then inside these brackets you put a number. What number do you put? Well, depends on what number A is. So if I was doing the problem that I just did right here, I would say that that second one I drew was a vertical stretch by a factor of 5. So it's always vertical stretch by, and you put the number that's in front. And that's it. But this is the answer to the problem. You don't have to write a formula. You don't have to draw a picture. You have to write the sentence. Vertical stretch by factor of, and then write down the number that you stretched it by. Now, somebody, I think, told us this earlier, but if A was negative, what did the negative cause the graph to do? I showed you guys of a picture. I think I did like 3 and then negative 3. Yeah, it caused it to flip. Which way did it flip? Did it flip over the x-axis, or did it flip over the y-axis? Yeah? Yeah, it flipped over the x-axis, because we went from something like that to something like that. So if you have a value that's negative for A, well, now you have to write 2 things. I'll show you what it is. So, under the part where it says written like, you would say vertical stretch by factor of A. So that part's the same as what you just did up above. And add the second part, reflect over the x-axis. So when it's a negative, you've got to add this part in at the end. We'll try 2 examples of that, and then that'll be it. Okay, so let's look at this one. This is example 4A. It says compare the graph of y equals 4 times 2 to the x with the graph of y equals 2 to the x. So the difference is this one has a 4 in front, this one doesn't. Let's think back. Is 4 positive number or negative number? Yeah? Positive. So, since a value here is bigger than 1, okay, that's definitely bigger than 1, 4 is bigger than 1, we're going to write the answer like this. Vertical stretch by factor of, and then we'll fill in the number. So what are we stretching this one by? Like if you graph this one and that one, this one would be stretched how many times vertically? Yeah. Yeah. This one would be stretched 4 times as much as this one. So what's the sentence that we write down to describe that? Perfect. Vertical stretch by factor of, and that's all you write. That's how you compare those 2 graphs. This one is stretched 4 times as much as that. right, let's try 4b. All right, it says to compare y equals negative 3 times 4 to the x with y equals 4 to the x. So you're going to focus on this number. That's the number that's causing something to happen. Is that negative 3 a positive or a negative? Yeah, it's a negative. So let's go back and read what we do for a negative. For a negative, you need to write a sentence like this, because a is negative. Right? So the first thing we want to write down is the vertical stretch. And for that, all you want to do is focus on that number. Don't worry about the negative yet. We'll write the negative second. So how would you describe what the 3 is doing? What would be the sentence you would write? Think about doing it just like the last one. And then we'll pretend like the negative's not even there. Yeah. Vertical stretch, perfect. By factor of 3. Now, if that was the problem, we'd be done. We would just say vertical stretch by a factor of 3 and stop. But there's a negative. So what's the thing that I have to add after it? Because there's a negative in front of the 3. Yep? Yep, perfect. Reflect over x-axis. So when you see a problem that says compare, you're either going to write vertical stretch by factor of a number, or that, and then a reflection over the x-axis. So homework tonight is on Schoology, and it's 6364, part 1.